All right, today we're going to be doing systems of equations, although we're going to start off first with a review from what you learned back in Algebra 1. Um, we're going to focus mostly on substitution methods. In Algebra 1, you learned how to solve a system of equations, linear equations, um, by graphing, substitution, and something called a linear combination um, or addition. So we are going to be leading up to solving quadratics, but we want to review our Algebra 1 systems first. Okay, so first of all, what is a solution? A solution to a system is where we're going to talk about lines, where they intersect. Okay, two lines can intersect in one point. It's an ordered pair. You can have parallel lines, so you're going to have no solutions or none. This would be one. And then we have something called coinciding lines, where that line is on top of the same line. So we call that coinciding. Sorry, I'm not used to this pen. It's a new thing. Coinciding lines. In other words, they're on top of each other. Think about it. Coinciding, like you have track practice the same time as a recital. So you have two things coinciding at the same time. So this is when they have infinitely many solutions. I don't know what's up with this pen, sorry. Well, it's written right here. Infinitely many. I'm struggling with this new pen. I got to figure this out. Anyway, I'm going to keep going. I'm going to trudge through this. Okay, so let's just kind of take a look of what that looks like. This is also a nice review of graphing lines as well. So a system can have of two lines. When you have two lines, you can have three things: one solution, no solutions, or infinitely many solutions. All right, so I'll just graph these lines here. You have a y-intercept of a -5, and it's up 5 over 1. Oops, that's not up 5, is it? 1, 2, 3. This is up here, sorry. 1, 2, 3, 4, 5 over 1. Okay, see if I can connect those. Okay, something like that. Yes, I know it needs arrows, but bear with me. And then I'm going to change colors here. Let's do 2x plus 1. So y-intercept is 1, up 2 over 1, up 2 over 1. Boom, we got an intersection. So again, oops, I totally missed that. Let's try that again. You can see that it intersects here at the point 2, 1, 2, 3, 4, 5. Oops. Intersects at the point 2, 5. So there's one solution. Okay, so 1. These two lines, you can probably guess by looking at their slopes. The slopes are the same. If you recall from Algebra 1 and just graphing in general, you've got, this is -5. You've got a line that has the same slope, different y-intercepts. Okay. I got this right here. And then we'll graph the 1, 2, 3, 2, 3, 4, 5 over 1. So you can see here, if I go to connect these guys, well, I kind of missed the points, but you see they're parallel. Okay, so this has no solutions. The y-intercepts have to be different, obviously. Okay, and the reason why I say that, because we look at this situation right here, I can go graph that line again, 5x minus 5. And then in order to graph this guy, I need to get y by itself. So I'm going to subtract 20x from both sides. And then I'm going to divide everything through by -4. And we're going to get y equals positive 5y minus 5. And as you can see, that's the same line. You didn't know it at the beginning, but until once you got y by itself, you have the same line. So this is infinitely many solutions because all the points are in common. They lie on top of each other. Okay, so let's do some algebraically. So that was just solving graphically. And now let's take a look at substitution. This is the practice that leads up to what the new content. So if you have y equals 7 minus x, and this y equals x minus 11, well, if y equals that and y also equals that, you can set them equal to each other. Because y equals this and y equals that, so this has to equal that. All right, so get your x's on the same side. I'm going to add x to both sides. And then I'm going to add 11. And I solve for x. So I get x is 9. Now we're not done. The x is 9 is just the x coordinate of where these guys intersect without graphing, okay? You guys are more than welcome to use Desmos to check answers after you solve it algebraically, throw these equations in Desmos and find their intersection. Otherwise you shouldn't really be using a calculator on any of these. But I'm not done. So x is 9. Here, it doesn't matter which equation to plug it into. Let's say I plug it into the first one. 7 minus 9 is a negative 2. I can check down here too. If I put a 9 right here, 9 minus 11 is a negative 2. So these two lines intersect at 9, negative 2. They have no other points in common. Two lines can only intersect at one spot or all the spots, all the points. Okay, so here is another substitution. Here I had y equaling y. Here I can take this and I can substitute it in for that y. And so it eliminates, because I have two equations with two unknowns, and I really would like to have one equation with one unknown. So that's what we're going to do here. Make sure you use parentheses when you use that substitution, because you're going to distribute here. Sorry, I'm getting used to the pen. It'll get better, I think. 6 times negative 1/2 is a negative 3. 6 times 2 is 12. What happens to these 3x and a negative 3x? Oh my. X is canceled, and we're left with 12 equals 18. So what do you think that means? They don't intersect, right? Because they don't intersect, we don't have an x equals or y equals, either one. So the variables canceled, I'm left with something that's not true. This is called a false statement. When you have a false statement, that means no solutions. Now, if I had done something similar to this and my x is canceled and I got something like 12 equals 12, if I get a true statement, then that's infinitely many solutions. Okay, so if the variables get canceled, you're either going to have no solutions or infinitely many, and it's based on whether you have a true statement or a false statement. Okay, and 12 does not equal 18, so a false statement gives you no solutions. Okay, let's try another substitution. Put that into here. There's lots of ways to do these. This is just sort of maybe the most obvious. I don't know. We could have gotten y by itself in the second equation. We could have gotten y by itself here, divide everything through by 2, and then set the equations equal to each other. But I'm just going to use a substitution where I'm going to take this expression and plug it in for y. So negative 2x plus 8 equals negative 2x plus 8. And what do you think that means? I add 2x to both sides, they go away, and I'm left with 8 equals 8, or even 0 goes 0. This means infinitely many solutions. Okay. All right. Not really gonna do those, but you're gonna be working on substitution here. Okay, so you can finish those. You can check them on Desmos as well. All right, we are gonna go on to quadratics. Okay, analyzing a systems of quadratics. All right, so we have a quadratic and a line, and also the intersection of two quadratics. So we have, one second here. So here we have a quadratic and a line, and you notice they can intersect at 2 places. It looks like that would be 1, 2, 3, 4, 0. Oh, let's circle 2 or more. 4, 0, and 1, 3. What if you have a quadratic and a line that only just hits this at this little vertex here, and it's a little called a point of tangency? That's going to be one solution. and that is going to be -2 and 5. -2, 5 is that ordered pair. Then we have two quadratics. So two quadratics, think about it first. Well, we're going to get there, but when we have two quadratics, they don't have to intersect at all. They can intersect in one spot, and they can intersect at two spots, and guess what? They might be able to at 4 spots. That depends. All right, so let's see. This one has 2, and we're here and here. So we're looking at 1, 1, and -1, 5. This one has no solutions. Now here we have a circle, which of course is not a quadratic, but you can see here you can have, there's 3 solutions here. What do we got? -3, 4, I think. 3, 4, and 0, -5. This one has none. Now this one is a circle, a line, and a parabola. So I want to know where all 3 of them intersect. Right here, and looks like right here. So this one has 2 or more. Looks like 1, 0, and 5, 2. Now from a picture, that's a little easy. Not when it's requiring us to do algebra. All right, so most of these we're going to be using straight up substitution, setting one equation equal to the other. You need to be really careful with your factoring. We're going to do quite a bit of factoring, but we're going to do as many as we can without making this video painful, more painful, I guess. All right, let's do it. I have y equals this quadratic and y equals that quadratic, so I'm going to set this equal to that. Okay, let's get everything set equal to 0. These are quadratics. Likely we want to have these set equal to 0 so that we can perhaps factor and solve. So add x squared to both sides. Add 2x to both sides. And I'm going to subtract 3 from both sides. Okay, I didn't show the work, but hopefully you can see I've added the x squared over here, added the 2x, subtracted the 3. Okay, I'm going to factor out a 2 to make my factoring easier. Hopefully it's factorable, right? All right, so what multiplies to be a -3 and adds to be 2? So right now we're trying to find the x values of where these two quadratics intersect, if at all. So I'm going to factor this into x plus 3, x minus 1. And I get -3 and 1. So we get 2 values for x, so that means we're going to have 2 places of intersection. Now, when you go to solve, you definitely want to choose the quadratic that maybe has less negatives, something a little bit easier, because you don't want to make mistakes. You don't get a calculator for this. So I'm just going to come down to the bottom here and maybe even extend this page. I'm going to need some places to show some substitution. So come down here, I'm going to do y equals, by the way, we don't all, oops, I don't know what I just did there. What did I just do? Go away. Oh my gosh, I don't know how to get rid of that. What did I hit? Let's try erasing that. You don't always get x by itself, so just be prepared for that. Unfortunately, I think we have a lot of quadratics that are in this form. All right, so we have -3 squared plus 2 times -3 minus 3. 9 minus 6 minus 3. 9 minus 6 is 3. 3 minus 3 is 0. So one of our places of intersection is the -3, 0. Right, let's plug in the 1. Now there is something we have to be careful of, and I'll show you that to you on the next example. It does matter where you plug it in. I mean, of course, you're plugging in for x in this example, but if you have a quadratic and a line, you actually have to substitute it into a line. Otherwise, you're going to get extraneous solutions. All right, so let me get back to here. All right, so we have 1 plus 2 minus 3. 3 minus 3 is 0. So at 1, 0. Okay, so those are your solutions there. Okay, let's try the next one. All right, so here I'll set negative 8x equaling to 1 plus 16x squared. I have a quadratic. Let's get a set equal to 0. So 0 equals 16x squared. Add 8x to both sides. Put it in descending order. Okay, and let's go ahead and factor this. This one is a perfect square trinomial. So this is 4x plus 1 and 4x plus 1. And unfortunately, we get negative 1/4. Yes, it is a double root. That does not mean it intersects it twice, okay? It means you have one x value. Now, this matters where you plug it in, okay? If you have x is a negative 1/4, you have to plug it into the smaller of the two functions, meaning the smaller exponent. So this is a quadratic and this is a line. You must plug it into the line. Otherwise, you're going to get extraneous solutions. So negative 8 times a negative 1/4 is a positive 2. So the line and this quadratic intersect at negative 1/4, 2. Okay. This next example is also an interesting one. Let's go ahead and get y by itself here. We get y equals negative 8x minus 4. And then let's set our equations equal to each other. We have a line and a quadratic. Okay, so we could have none, one, or two solutions. All right, so it's a quadratic. Let's get this set equal to 0. Add 8x to both sides. So that's going to be plus 4x. Add 4, so that's plus 6. And then we ask ourselves, okay, x squared plus 4x plus 6, we're going to try to factor that. Well, multiplies to be 6 and adds to be 4. Nothing. That doesn't mean there's no solutions. It means it's not factorable. This is a perfect candidate for completing the square. We have to solve for x. You can use the quadratic formula if you want, but this one is a really easy one to do, complete the square. So I'm going to do that. So I'm going to kick negative 6 to the other side. So subtract 6. And remember, completing the square, we're going to take half of 4 and square it. So half of 4 is 2. 2 squared is 4. Make sure you add that to both sides. We have x plus 2 now, quantity squared, equals negative 2. And I'm going to go take the square root. And as soon as I take that square root, I can stop because I have an imaginary solution here. Because I'm taking the square root of a negative number, you do not need to finish this. I would like you to write imaginary. Okay, you don't need to finish solving this because if it's imaginary, that means there's no solutions. But you have to get it down to this part where you're taking a square root of a negative number. Okay, no solutions. All right, we're going to do some more examples. I'm probably not going to do all of these, but I want to definitely want to do a couple special ones, I guess. Let's go ahead and do the first one. I think I'd like to get y by itself on the first equation. So subtract x. All right, so I'm going to have negative x plus 5 equals the other equation. Now your job is to get everything on one side because we're going to try to factor it. So 0 equals, I'm going to add x. I'm going to subtract 5. All right, to make that easier, I'm going to factor out a 3. I have a 3 in common everywhere. And I'm going to see if I can factor that. Are there two numbers that when I multiply them, I get a negative 2, and when I add them, I get 1? Yes, indeed. The 3 can divide out. This is x plus 2, x minus 1. So we get negative 2 and 1. So this tells us we're going to have two solutions. All right, and now you must plug these into the first equation. In fact, I'd plug it into this one. You have to plug it into line. All right, so y equals negative 2 plus 5. So y equals 7. So I have 1 point at negative 2, 7. And then I'm going to plug in 1. And that's going to be 4. So here are two ordered pairs, negative 2, 7, and 1, 4. All right, I want to take it down to yeah, we'll go ahead and do the one underneath it. No, we'll do one with the a quadratic. Let's do actually we'll do both of these right here. All right, set them equal to each other. If y equals this and y equals that, then this equals that. All right, I think I want to get everything over to the left. I don't want a negative x squared, so I'm going to go ahead and make everything go to the right. So subtract x squared, add 6x, subtract 14. So if you want me to show that, minus x squared plus 6x minus 14 plus x squared plus 6x. So this is plus 9. So here we get a nice little perfect square trinomial. So we get 3. Yes, it's a double root. That does not mean it intersects it twice. It just means that 3 is one of your solutions. So 3. All right, let's find the y value. 3 is the x coordinate of the intersection. I'm going to use the first one. That one's easier, right? So that's 9 minus 9 plus 14, right? 9 minus 9. Yep. Okay, so that's going to be 14. Did I do something wrong? That's not 9. No, it's 9. Let's try that again. Let's try that again. Yuck. That was bad math. All right, so let's try that again. 3 squared minus 6 times 3 plus 14. All right, so that's 9 minus 18 plus 14. So negative 9 plus 14 is 5. Okay, so those two quadratics intersect at 3, 5. And again, if you want to throw that into Desmos and check your answers, go for it. All right, so this next one is gonna be a lot more algebra to set them up equal to each other. Let's check that out. We're gonna have to do a little bit of foiling, okay? So we're gonna have negative, and then we're gonna FOIL this out, okay? So that's x minus 2, x minus 2. So that's going to be x squared minus 4x plus 4. Don't forget the plus 5 equals negative x plus 1. Let's distribute that negative through there, and we're going to combine like terms as well after we do that. So negative x squared plus 4x. Now this is going to be a minus 4, right? This will be minus 4 plus 5, so it's a plus 1. Right? I'm going to have a negative 4 here, and then I'm going to add 5 to that. So I also don't love this negative x squared, so I'm going to get everything over to the right-hand side. So I'm going to add x squared to the other side. There's no other x squared, so it's just adding x squared. Subtract 4x. Subtract 1. Well, those cancel, right? If we need to show the work, minus 4x, minus 4x, minus 1, minus 1. Okay? Factor. All right, so the x coordinates here are 0 and 5. So this intersects twice. You must plug it into the first equation. You must plug it into line. So y equals negative 0 plus 1. So that's 0, 1. And then we'll do y equals negative 5 plus 1, so it's negative 4. Okay, I will have the key posted for you, but I think that's all I really wanted to show you here. You do have some special, oh no, I think, let's see here. I can do this last one for you. We can do the last one. This one will be a special one. All right, let's set it equal to each other. I don't like the negative 2x squared, so I'm going to get everything over to the right. So add 2x squared, add 4x, add 1. There is nothing that I can find that multiplies b10 and adds b6, okay? This is not factorable. Doesn't mean it's not solvable. It means it's not factorable. So I need to use a different method. I don't love this one for complete the square. First of all, I don't have a leading coefficient of 1. As soon as I divide through by 2, that gives me an odd value of x, which I don't like that either. So I'm going to use a quadratic formula here. Okay, the opposite of b, plus or minus, square root, b squared minus 4 times a times c, all over 2 times a. Negative 6 plus or minus. So 5 times 2 is 10. 10 times 4 is 40. 36 minus 40 is a negative 4 over 4. And at this point, I can stop. Stop. Imaginary roots. Okay, imaginary. Do you know what these 3 dots is? You're going to see it all the time. That means therefore. Oh my gosh, I don't know why it's doing that. So this is no solutions. Okay, these don't intersect. All right, I'm going to do a couple more examples, maybe just one, maybe 2, I don't know. We are going to look at when you have 2 circles or 2 ellipses or 2 hyperbolas, which I know a lot of you don't know what those are, but they're different conic shapes. But I want to show you how we can solve some of them. I actually want to start with, I don't want to start with that one. I want to do this one right here. Okay, so what in the world? How do we do this? So back in Algebra 1, you were taught to a method called elimination, where you manipulated one of the equations and then you added the columns. I'm going to show that method on this one. You may not remember how to do that, but if I subtract this function from the top, actually that's not a function, sorry. If we subtract this from the top, I can get 3x squared, y squared minus y squared, that cancels, equals, I don't know what that equals, 3, okay, 13 minus 10. So I divide by 3, and I get plus or minus 1 when I solve for x. So this tells me that I've got at least 2 solutions. Okay, another method that you could have used on this one, I'm just going to kind of come back here and erase this. Another way you could have done this one is to get like y squared by itself, for example, or even x squared by itself. I could have gotten this x squared by itself and got it done 10 minus y squared. That's probably not the best choice. But then I can take this and put it into here, and that would be 4, 10 minus y squared plus y squared equals 13. I would distribute, and I get 10 minus 3y squared equals 13. I would subtract 10. I don't know, I'm getting a minus. 10 minus y squared. I have to go back, sorry. I'm rushing. Give me a second. Okay, so sorry about that. I wanted to show you guys how you could get solve for y instead. If I made this like I just showed you, x squared equals 10 minus y squared, I can take that and take this and plug it into the x squared. So that I'm going to go up here, 4 10 minus y squared plus y squared equals 13. 40 minus 10y squared plus y squared equals 13. So that's a negative 9y squared. I'm going to subtract 40. It's a negative 27. Y squared equals, I think I messed that up. 40 minus, that's not 10. Sorry. 4y squared. Oh, God. Oh, my God. You guys are losing your mind right now. Let me try that one more time. 4 10 minus y squared. Okay, so we have a negative 3y squared equals a negative 27. Y squared equals 9. And we get y equals plus or minus 3. The reason why I'm showing you this is that you can have a place where you're finding the y values, or you can do a method where you find the x values. It's just a matter of what you feel like is easier. That probably wasn't, I probably could have just done y squared by itself and made that 10 minus x squared and then substituted it in for this y squared. Either way, we're ready to find the other ordered pair. So when x is 1, or when x is negative 1, it doesn't really matter. I'm going to use both of these because it doesn't matter. If it doesn't matter if it's negative 1 or positive 1, when I go to square it, it's always positive. So this is going to be 1 plus y squared. So we have y squared equals 9, and that's plus or minus 3. So what we just found, guys, is really interesting. So when x is 1, we get 3, x is 1. Yeah. Oh my God. Sorry for the distraction. So when x is 1, we get 3. When x is 1, I get a negative 3. And when x is negative 1, I get 3. And x is negative 1, I get a negative 3. So we have 4 places where these are 2 circles. So that's kind of cool, right? That's not 2 circles. That is an ellipse. The second one, the bottom was a circle. The top one is something called an ellipse. So it's like this and this, something like that. These are the 4. I don't know if I can go on for another one. You guys are getting a very poor lesson, poor video here. Let's do this first one up here. And then I'm going to call it a quits because it's terrible. All right. Okay, let's try this. All right, so I have x squared minus 3y squared, x squared plus this. I need to get one of these variables by itself. I'm just going to use this one. I'm going to say x squared equals 3y squared minus 8. I'm just going to take the get this x squared by itself, and then I'm going to take this and I'm going to plug it in for this x squared. So for this x squared, I'm going to say 3y squared minus 8. And finish the rest of this equation. Combine like terms, 5y squared minus 8 equals 12. Y squared equals 4, and we have y equals plus or minus 2. You guys have to remember, every time you take the square root, you're going to have plus or minus. So here we have our y values at 2 and a negative 2. Now we're going to plug it back in. So we'll plug it in here, and we'll do x squared. I'm going to use this one, okay? X squared plus 2, and it doesn't matter if I plug in a 2 or a negative 2, no matter what, I'm going to square that, and that's always going to be 4. So I don't really need to do this twice. I can put plus or minus 2 in here because it's always going to give me 4. So I have x squared plus, this is going to be 4. 4 times 2, 8. x squared equals 4x equals plus or minus 2. Woo, what that tells us, we have 4 solutions again. So when x is 2, y is 2. When x is 2, y is negative 2. When x is a negative 2, y is 2. And when x is negative 2, y is negative 2. So you have 4 places of intersection. All right, I got to call that a day. That was a terrible video. But hopefully this helps to some extent.